Alright, this is lesson 1.11 for our Pre-Calc 12 class. Unit 1 is called Functions and Transformations. Lesson 11 is called Inverse Functions. In this lesson, we're going to talk about what is an inverse function, how to tell if a function is an inverse, and then how to find the inverse of a function. So first of all, an inverse function is a function that undoes the actions of another function. So, for example, if you put x inside of f and you get a y as an output, g would be the inverse of f if and only if you put y inside of g and it spits back out x. So mapping wise, it looks like, okay, if I put, if my domain is 1, 2, 3, 4, and I put those numbers into f, I get a, b, c, or d. G would be a function that I could put a, b, c, d into, and it would spit back 1, 2, 3, 4. In other words, f of 1 is a, and g of a would be 1. Or f of 2 is c, and g of c would be 2. There's nothing magical about these particular sets. It just highlights the relationship between a function, f, and its inverse, g. Okay. Let's see here. Alright, so here's the notation we use when we write inverse functions. It looks like it's a letter, and it looks like it has an exponent of -1. That is not an exponent. That just means the inverse function of f. So if f of x is a function f, f inverse of x will be the inverse function of f. Two ways we say it: the inverse of f of x, or f inverse of x. Two common ways to say that. Alright, consider these functions. F is 2x plus 6. G of x is 1/2 x minus 3. If we want to see if g is an inverse of f, we can try some examples. For example, if I put 1 into f, I get 8. If I take 8 and put it into g, it goes back to being 1. Looks like it could be. Let's try some more examples. And you could keep trying examples until you're convinced that g is in fact the inverse. We put 2 inside of f, calculate that, we get 10. Put 10 inside of g, do the calculations, we get 2. Goes back to being 2. 3 in f goes to 12. 12 in g goes back to 3. So we haven't proven anything, but it appears that g might be the inverse function of f. In other words, g of x is equal to f inverse of x. Okay, so if that's true, then we can also conclude that f of x would be the inverse of g. If g is the inverse of f, then f is the inverse of g. G undoes f, but f undoes g. Makes sense. Okay, so if I'm given an expression f, and I want to find f inverse of x, there's a simple process. Because f of x is function notation, I could write it as an equation, which means I take the f of x out and put y in its place. To find the inverse, we're swapping the x's and y's. And that's what inverse means. So I'm just going to replace the x, or the y with x, and the x with y. I get a new equation. I solve that new equation for the new y. Boom, boom, boom. And I get the inverse expression. So 1/2 x minus 3 would be f inverse of x. Again, step 1, swap the x's and y's. Step 2, solve for the new y. That's the process for finding the inverse function. Some examples here. If I'm looking at a graph, and I have, okay, here's this red line is f of x, and I want to graph the inverse function, or f inverse. And think of the domain and range. So on this graph, I see that 0, 1 is a point on the original f graph. Our mapping, 0 goes to -1. For f inverse, it's going to take the range and send it back to the domain. So -1 is going to go back to 0, which means the point -1, 0 is going to be on our inverse graph. So I'm going to plot -1, 0. 0, -1 goes to -1, 0. We could do that with more points. 3, -2 is on the original f graph. So So negative 2, 3, swap the x's and y's, would be on the inverse graph. And we can see we're getting another line here. The pattern with this is that if I graph this yellow line, which is y equals x, this is the line of reflection. Any graph and its inverse are going to just be reflected over that yellow line. Always that same yellow line. That's not super important for your homework, but it's good to know. All right, that was a glitch. Find the inverse function. All right, so here's a couple examples. If I want to find the inverse function, I'm going to swap the x and y's, and I'm going to solve for the new y. So in this case, we just have some simple algebraic manipulation. Subtract 9 from each side. And then I have negative 1/3 y, so I'm going to multiply each side by negative 3, or the reciprocal, and I'll get y by itself. We have negative 3x plus 27 equals y, so negative 3x plus 27 is the inverse function of f. Second example, for g, I'm going to swap the x's and y's, solve for the new y, and that's our inverse function. All right, here's a x to the power of 5 function. If I'm going to find the inverse, I'm going to swap the x's and y's. The manipulation for solving for y, once we get y to the power of 5 by itself, to undo the power of 5, we're going to take the fifth root of each side. So the fifth root of y to the power of 5 is just y. The fifth root and the 5 exponent are inverse operations, so they cancel each other out. So our inverse function is the fifth root of 1/3 x minus 1/3. Boom. J is actually a linear function, but it's written like a fraction, so we'll treat it like a fraction. First thing we're going to do is multiply each side. Well, first thing we're going to do is swap the x's and y's. Then we'll do the manipulation, multiply each side by 5, and then add 2. So here's our inverse function, or J inverse. Here's another linear example. This one's kind of factored a little bit. So we'll divide each side by 7, and then add 1. P of x is a cube root function. Remember, for h of x, we had x to the power of 5, and we ended up with an inverse with a fifth root. It's going to be the exact opposite process for p of x. We're starting with a third root, so once we get rid of that 5, we're going to take each side to the power of 3. So we're going to end up with an x to the power of 3 function. I would say there's two different ways to write the expression of the inverse for this p, or p inverse. You could write the 1 over 125 as the coefficient on the x to the power of 3, or you can make x to the power of 3 a fraction over 125. Either way is fully acceptable. Alright, some takeaways from this lesson. We now know the notation for inverse functions. We understand an inverse function to take outputs and assign them back to the original inputs from which they came. And we know how to find an inverse function. Given an expression, you just swap the x's and y's and solve for the new y. One side note, and this is the tie back to a bunch of lessons ago, a function's inverse isn't necessarily a function. Think about our mapping. If 1 and 2 is our domain and they both map to 3, there's only one arrow coming out of each element in the domain, which makes it a function. But the inverse would be taking each number in the output and sending it back to its original input. In this case, since 3 has 2 arrows going into it, it's ambiguous as to does 3 go to 1 or does 3 go to 2. So the inverse of whatever this function is, the inverse would not be a function. It's a good side note, but not super important for our homework. Anyways, good luck on your homework.